Need to generate consistent, reusable LLM prompts without hard-coding message templates everywhere? You'll see how FastMCP, S at MCP, Prompt Decorator turns simple Python functions into parameterized prompt templates, automatically handling string conversion, type validation, and even structured message objects. We'll define two practical examples: a basic string-based prompt and a more advanced version returning a full prompt message with role and content metadata.
From FastMCP, import FastMCP. From FastMCP prompts prompt import message, prompt message, text content. MCP equals FastMCP, name equals prompt server. Hash basic prompt returning a string, converted to user message automatically. At MCP, prompt. Def ask about topic, SDR. Generates a user message asking for an explanation of a topic. Return F, can you please explain the concept of topic? Hash prompt returning a specific message type. At MCP, prompt. Def generate code request, language, SDR task description, SDR prompt message. Generates a user message requesting code generation. Content equals F, write a language function that performs the following task. Task description. Return prompt message, role equals user. Content equals text content, type equals text equals content.
This demonstrates the prompt has function pattern, where reusable LLM interaction templates are defined as Python functions with declarative metadata. The key concept is treating prompts as first-class components with explicit input-output contracts, rather than ad hoc strings buried in application logic. What makes this distinctive is the dual nature of these functions. They serve as both executable code for dynamic generation and as self-documenting templates for LLM interactions. The pattern works by leveraging Python's decorator system to create a registry of parameterized message templates. FastMCP handles the conversion between Python's type system and the string-based MCP protocol, automatically generating validation schemas and metadata from function signatures. This creates a clean separation where prompt logic lives alongside your application code, but remains independently discoverable and reusable across different LLM workflows. This approach solves the problem of prompt fragmentation and inconsistency in LLM applications. By centralizing prompt definitions, you eliminate duplicate or conflicting instructions across your codebase, while the type-safe interface prevents runtime errors from malformed inputs. The pattern shines in collaborative environments or when building reusable AI components, though it does require adopting FastMCP's opinionated structure for prompt management. Let's break it down line by line.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for defining AI-callable tools and prompts. It's the foundation that bridges your Python functions with AI model interactions, handling serialization, validation, and execution.
From FastMCP prompts prompt import message, prompt message, text content.
Imports the FastMCP prompt system types. Message defines the base message structure. Prompt message handles role-based messages like user assistant, and text content standardizes text payloads for consistent AI processing. These types enforce structured communication between your code and AI models.
MCP equals FastMCP, name equals prompt server.
This initializes the FastMCP server instance named prompt server, the central orchestrator for all AI-callable prompts. The name parameter identifies this server in logs and when exposing endpoints, enabling clear separation between multiple MCP instances in larger systems.
Hash basic prompt returning a string, converted to user message automatically. At MCP, prompt.
The @MCP prompt decorator registers this function as an AI callable prompt generator. FastMCP automatically converts string returns into properly formatted user messages, eliminating manual message construction. This pattern standardizes prompt generation across your application.
Def ask about topic, SDR.
This defines a prompt function that takes a topic string and returns a string. The return value automatically converts to a user message in the AI conversation, simplifying prompt creation by handling the message formatting internally.
Generates a user message asking for an explanation of a topic.
This is the function's docstring, serving as both human-readable documentation and AI tool schema. FastMCP uses it to generate the tool's description and purpose, ensuring AI models understand when and how to call this function.
Return F. Can you please explain the concept of topic?
This returns a formatted string that becomes the AI's user message. The decorator automatically converts the string return value into a properly structured message object, eliminating manual message construction boilerplate.
Hash prompt returning a specific message type. @MCP prompt.
The @MCP prompt decorator registers this function as an AI callable prompt generator. Unlike the basic string return version, this explicitly structures the output as a PromptMessage object, giving full control over role assignment and content formatting.
Def generate code request, language, SDR task description, SDR prompt message.
This defines a prompt function that returns a structured prompt message instead of raw text. The structured format enables precise role assignment and content typing, which is essential for complex AI interactions where message metadata matters.
Generates a user message requesting code generation.
This docstring defines the function's purpose for AI tool discovery. FastMCP uses it to generate tool documentation and validate usage, ensuring the AI understands what this prompt generates before calling it.
Content equals F. Write a language function that performs the following task. Task description.
This constructs the natural language instruction for code generation. It dynamically inserts the target programming language and task description into a clear, actionable prompt, ensuring the AI receives precise requirements without manual string formatting.
Return prompt message, role equals user. Content equals text content, type equals text, text equals content.
This constructs a structured PromptMessage object, explicitly defining the message role and content type. The text content wrapper ensures type safety and enables future extensions like multimodal content, while the explicit user role distinguishes this as an AI-directed instruction rather than system metadata. Prompt engineering pattern. FastMCP's @MCP. Prompt decorator transforms Python functions into reusable AI message templates, automatically handling parameter validation and message formatting. Default string returns are converted to user messages, but returning prompt message objects gives you explicit control over role and content structure. The function signature becomes your API contract. Required parameters enforce structure, while optional parameters maintain flexibility.
The prompt that speaks in silence becomes the most eloquent conversation.